Now, it's quite important to understand the differences between the implicit and the explicit creation of a string. Why there exists two different types of initialization of a string. Now, before we begin, there's something I'd like to tell first. That is, uh, to my right, I have the snapshot of the main memory or a segment of the main memory. Now, whenever we run our program, the variables are allocated memory on the RAM, on the main memory, right? And every data or every item that is stored in the memory has two parts. One is known as the data or the content of the item, and another is the address of the item in memory. All right, so two parts: item, a data, and address. All right. So let's take the example of the implicit creation of a string. So here we have created a string str1 and assigned it the string literal bat. All right. So when we do this, then what JVM does, it takes the value or the string literal and assigns it a location on the main memory. And let's say bat has been placed at a memory location having an address 1000. And this would conveniently mean that str1 basically refers to this particular location in memory for its value. Now, if we want to create another variable, let's say str2, for instance, and if we assign it the same string literal as before, then the JVM uh, will perform the following tasks. So instead of allocating a separate memory location and storing BAT in a separate memory location, what would JVM end up doing is it would tell or assign the reference str2, and it would tell str2 to refer to this location in memory which already contains the string literal bat. Now, why does JVM do this? JVM does this to save on memory space because the storage of a string is costly. Why? To answer that, first we need to know what is the size of a character variable in Java. So the size of the character data type in Java is 2 bytes. Now, the string literal, our string literal consists of 3 characters. Now, because each character takes up 2 bytes of memory, therefore, in total, the size of BAT is 6 bytes. Now, if JVM would have allocated a separate space in the memory and I'll have duplicated the content of BAT there as well, then we would in total be utilizing 6 or not 6, 6 plus 6, that's 12 bytes of memory. Moreover, if the same thing had occurred several times, for example, if we would have created str3 next and assigned it the value BAT again, then for that it would also allocate a separate memory location, and now the total memory utilized would have been 6 plus 6 plus 6, and that would have been 18. Instead, if upon creating a new variable which supposedly has a string literal that already exists in the memory, then it's better to assign a reference, or better to assign a reference to the already existing literal in the memory, right? And this saves on space. No matter how many variables we create with and assign it the value BAT, we would only end up using just 6 bytes of memory. Instead of currently, if separate memory spaces were created, then we would have required 18 bytes of memory. Though 18 bytes and 6 bytes don't make a lot of difference for you, but imagine what it would do for a program as large as, let's say, PUBG. PUBG has so many strings that are displayed on the screen in menu item, in the game HUD or game window, right? So Java takes up this approach, and because it does, it saves on memory, and no matter how many variables we create and assign it the value back, we would only use 6 bytes of memory effectively. All right. Now, this particular location where the string constants are kept is also known as the string pool. So if a string constant is already available in the string pool, then Java would not create another uh, another would not allocate another memory location to create that same string literal. It would basically reutilize that string literal already in the string pool and save on space. All right. Now, what do you think would happen in case of explicit creation of a string? So, in case of explicit creation of a string, we use the new operator, right? So here we have created a string and stored it in str1. Therefore, bat would be assigned a memory location of, let's say, 2000, and there the item bat would be kept. Now, because we are explicitly creating a string, therefore what would happen is that even if we created another string which has a different variable name but has the same string literal, right? So if you have created str2 instead, to which we have assigned the same string literal, because we are explicitly creating a string, therefore it would allocate a separate space for the new string as well, for the same string, and str2 would be pointing to this reference instead, and let's say the address of this particular memory location is 3000. All right. So currently, the memory utilization is 12 bytes. So so creation of a string explicitly is not recommended from the memory utilization point of view. Moreover, we wouldn't want to create an string explicitly because it's writing too much, right? We have to write new, we have to write string, we have to put parentheses. So naturally, to reduce the amount of code that is written, people prefer using the implicit creation rather than the explicit creation of a string. Moreover, what do you think the output of this code will be? Well, because I had a space constraint, therefore I have written SOPLN instead of system.out.println. Right? So SOPLN stands for system.out.println, but you are not allowed to use the shortcut when you're giving an exam. Right? So in an exam, please don't use this shortcut because I didn't have space on the screen. I ended up using SOPLN. All right. So pause this video for a second and try to answer what the output of this code will be. So I hope you pause the video, and I think most of you would have answered equal, right? Now, but the thing is, the reason because of which you think equal would be printed, I think is slightly wrong. Now, you might be thinking because str1 and str2 contain the same string literal back, therefore, the conditional str1 is equals str2 is evaluating to true, and therefore equal is being printed. Well, that is not the case. str1 is equals str2, this particular condition is evaluating to true because str1 and str2 refer to the same item in memory which have the same address. And in here, we are comparing, or it is comparing the addresses of str1. It is not comparing the content of str1 with the content of str2, but it is comparing the address locations of str1 and str2, because of which we are printing equal. But if we run the same code when we have created a string explicitly, then this particular output would be not equals instead, although str1 and str2 contain the same string literal back, right? So you must keep this in your mind that whenever you are comparing two strings, never use the is equals relational operator. So a word of warning, never compare two strings or string values or string variables using the is equals operator, because you never know whether the string has been implicitly created or it has been explicitly created. Therefore, it's safer not to use this because we have other functions that can compare the content of two strings, whether they have been created implicitly or explicitly does not matter. All right, moving on. Now, we have to know the length of an array, we can conveniently use the length attribute of an array, and we can get what the size or the length of the array is, right? So For this particular array named chr, if we want to get the length of this array, then we would have written chr.length and would have got 4. Now, you must note one thing. That is, length is an attribute, right? It's an attribute or a data member of a class. It is not a method. And that is the reason why we do not put parenthesis over here. If you put parenthesis, your code will not compile. But if you let go of the parenthesis in case of an array, your code will compile and you will get the length or the number of items in the array. All right. Similarly, we also have we can also figure out or get the length of a string as well. But for finding out the length of a string, we need to call the length method on a string rather than a length attribute, right? So to get the length of this string, we would write str.length followed by a pair of parentheses. And this would fetch us 4. All right. So this is the point where students get confused. So please take your time to understand this fact that str.length is basically a method that we are calling on an object, and .length is an attribute that we are accessing on an object, on an array object, and here we are accessing the length method of a string object, right? So method and left is the attribute. So please don't get these two mixed up. Otherwise, your code wouldn't compile. All right. All right. Moving on. Next, we want to see how the arrays are indexed, right? So both arrays and strings are zero indexed. So for example, if you have an array with the contents being A, P, P, L, E, then the first element of the array would have an index or a position value of 0. All right. So to access the first element of the array, we would write the name of the array followed by a pair of square brackets, and inside that, because the first element has an index of 0, if we write 0, this would mean we are accessing the first element of an array. Now, in a similar fashion, we can access the first element of a string as well. But in case of a string, we must keep this in mind that although strings and character arrays are quite alike, they are not the same. And for accessing an element or any element in general in a string, we use the method char at. So, for example, to access the first character in the string, which has an index of 0, we would write str, which is the name of the string variable, dot char at, and passing index of the character that we want to access. In this case, that's 0 because the index of the first element of the string is 0, right? Now, in general, to access any element of the array or the ith element of the array, we would write arr I. All right. And here's a small exercise for you. So pause this video and try to solve this challenge. Store the character at index 3 of the array in a variable ch. So pause this video right now and try to solve this yourself with the knowledge that we have about indexing arrays. So I hope you pause the video, and the answer to this question is this: char ch equals arr 0, not 0, arr 3. Now, why did I use a character variable and not an int variable? Because our base type of the array is char, right? So the elements of the array will be characters, right? Char. Therefore, the variable in which we are storing an element of the array is char and not int, right? Now, if we want to access the ith element of the string, then we would still require to use the char at method. We cannot use the square bracket notation in case of a string, all right? So, to access the ith element, we would write str.char at I. Now, here's a small little exercise for you. Store the character at index 4 of the string in a variable named ch. Now, you must always remember that str.char always returns a char type. It never returns an int type, it never returns a double type, but it returns a char type. All right, and that is the reason why the name of the method is char and not something else. So, pause this video now and try to solve this for yourself. All right. So the uh, solution for this would be char ch. Remember that this is a string and not an array. Therefore, we need to use the char method to access the element at the fourth location. So str dot char at 4, and that's it. This is the solution to our problem. Right. Moving. The valid index range for an array is from 0 to ARR.length minus 1, right? Moreover, there's one property that I want to highlight first before we jump on to the valid index range of an array. Now, you see, arrays are mutable. Now, why are they mutable? Because arrays can be both read and written to, right? So, an example of reading from an array would be storing the element of an array in a variable, right? ARR0. This is an example of reading. Now, if I were to change the first element of the array to E, I would have written ARR0 equals E. Now, this is writing to an array or modifying an element from the array. Because the elements of the array can change, therefore, arrays are also referred to as a mutable data structure. I'm really sorry for this. I'm not well. All right. So, in case of a string, though the conditions are a little constrained, right? So strings can only be read from, and it cannot be written, right? So the strings are immutable, all right? So when strings are created, once a string has been created, we cannot change the contents of the string any further. But we can create a new string with the new content, but we cannot change the content of a string variable that has already been created. All right, we can assign another value to it, but the content of the string cannot be changed. Therefore, reading is valid. We can read a character, that would mean storing a character and a variable or displaying it. But if you would try to write str.char@0 equals a, this is invalid. And this would not occur. Why this would not occur? Well, see, the str.char@0 would return a character literal. So it would return E. Now, a character literal E cannot be assigned the value of A in much the same way that 1 cannot be assigned the value of 2, because a constant cannot contain a different value. The value of 1 will never be 2, it will always be 1, right? So this is the reason why we cannot assign value to str.char@, because it's basically returning a character literal of this from the string, right? So this is invalid. So strings can only be read from and it cannot be written. Therefore, the strings are also known as immutable. It does not mutate, it does not change, right? Okay. Now, the last aspect of indexing. Now, the valid index range of an array lies between 0 to ARR.length minus 1, where ARR is the name of the array. Therefore, for this array, which contains 5 elements, the valid index range would be from 0, let's change the color, would be from 0 to the ARR.length for this array would be 5. So 5 minus 1. So that's 0 to 4. All right. In much the same way, the valid index range for a string is also from 0 to the length of the string minus 1. And to get the length of the string, we write str.length with a pair of parentheses and minus 1. Okay. Now, for the string, let me delete that. For the string str, the valid index range is from 0 to str.length, which will give us 6 minus 1. So that's 0 to 5. Now, the upcoming slide is very important. You see, students often run into array index out of bounds exception and they are spellbound about what to do next. Well, why does array index out of bounds exception occur? So if you try to access an element of an array using an index which is less than the minimum valid index, that's 0, or if you try to use an index which is greater than the maximum valid index, that's era.length minus 1, then an array index out of bounds exception is raised. In much the same way, in case of a string, if you try to access an element which is not within the bounds of the valid index range of a string, what you would end up receiving is string index out of bounds exception when you run the program. So the thing that you need to keep in your mind is whenever you get an index out of bounds exception, that means you're trying to access an element which is invalid using an invalid index, right? So in these cases, primarily when you're using a loop, uh, using a for loop perhaps, you primarily run into these kinds of exceptions. So the test condition is the culprit there. Sometimes you write I less than equals str.length, whereas it should have been I less than str.length. Some of you might be having a few idea about this if you're habituated with array. If you're not an issue. But the point that we should keep in your mind is that if you run into index out of bounds exception, you should check the index variable which is responsible for accessing an element in the array, right? And that variable might be getting assigned invalid index, right? Okay.